Dates and times are an easy thing to get wrong in Excel, which wastes time and causes errors. I've seen many different approaches taken because users just don't realise how easy Excel makes it. I'm going to tell you everything you need to know about dates and times in Excel in under 5 minutes.
Excellent.
Dates and times are actually just numbers between 0 for January 1900 and 2.9 million for December 9999. Whole numbers represent dates and the decimal element represents the time, so 0.5 is 12 noon. Everything else is just formatting and makes no difference to the calculation. This table shows the same values in a few different ways. Pause the video, look at the different values, which are consistent on each row, and understand the difference between the date and the time elements. The key thing for me here is that every one of these values is the same number across the whole row. Even these words are actually still numbers, just formatted to look like words. And once you start to think of these as just numbers, whether a whole number or a decimal, the calculations start to make much more sense. Addition and subtraction become easier, and you understand rounding errors where a time is hidden within a date. They don't even need to be in date format to get the right answer. Formatting is irrelevant as long as the underlying number is right. So let's look at some formulas. First we have two volatile formulas, now and today. Now is this moment to the split second, and today is just the integer part. These values will update each time the file recalculates. Next, we can extract any meaningful part of a date or time using the basic formulas year, month, day, hour, minute and second. And we can then put these back together using the date formula, which needs year, month and day. So if we want to create a regular payment on, say, the 5th of the month, we can use date, year, month, 5. Another way of identifying a fixed day of the month is to use EDATE, which creates the same day of the month any number of months before or after another date. So EDATE date, 1 is the same day 1 month after a date. EDATE date, 3 would represent a quarterly payment. Similar to EDATE is EOMONTH, a really useful formula when working with timelines. This returns the last day of any month. So I start with a date, in this case the 1st of January, and use EOMONTH to get the last day of the month. I add 1 to it to get the first day of the next month, EOMONTH to return the last day of the month. I quickly build up a timeline of start and end dates that I can use as filters within COUNTIFs and SUMIFs on any set of calculations. And you can use equals day EOMONTH date to calculate the number of days in any month, which solves the whole problem of leap years, different days in each month, etc. Next, I want to look at the weekday formula. This returns a day of the week between 1 for Sunday and 7 for Saturday. And I can use this in conditional formatting to easily identify where my weekends are. Finally, I want to look at network days, which is another useful formula that's often overlooked and can confuse people. Network days returns the number of working days, weekdays, between any two dates, including those dates. So network days, 1st of December 2019 to 31st of December 2019, returns 22 working days. Except it shouldn't, because I haven't taken account of Christmas Day or Boxing Day. So instead, I want to include a range of dates that shouldn't be treated as working days. In this case, a list of all UK bank holidays. There are 2 dates in this range that fall in between December 2019, so the final answer is actually 20 working days. And that's it. These formulas and understanding how you're working with normal numbers regardless of formatting are everything I think you need to know. Head over to Gatcom Analytics/resources to get a download of this file and files supporting my other YouTube videos. If you like my work, please give a thumbs up and subscribe, as this helps to keep the channel running. Okay, thanks for watching.
Excellent.